Let's continue our study of complete sets of operations by looking at environment variables. Here's our problem statement. Write a program that simulates environment variables. Now we're going to use a bash shell style. This is typical for a Macintosh computer. I'll give you some PC hints along the way too. First, we want to read environment variables from a file. Then we want to add environment variables at the console, and then search for environment variables from the console. All this might make more sense if you knew what an environment variable was, so let's talk about that a little bit. Environment variables are used in computer systems to describe the location of critical files. So on a PC, you would go to Programs, Accessories, Command Prompt. A window will appear, type the word set, and it will show you all of the environment variables that are on your system. On a Macintosh, you go to the Launchpad, Other, Terminal, and enter the word set. So here we go on my Mac. Here's my Launchpad. Now I'm already in Other. Remember, normally it would look like this, and then you would go to Other, and here's my terminal. And then I'll enter set, and a whole bunch of stuff is going to go whizzing by. All of these are the environment variables that are currently set in my system. So notice there are a lot of them. What exactly gets stored? Well, for example, the path is stored. What this is a list of directories, otherwise known as folders, that the system will search to find commands. There's one called home, and what that is a location of my user home directory. In other words, the default place that files get put. There's also something called hist file size. And what that is the number of user commands that are remembered. So it will actually remember the last 500 commands that were typed in. That's kind of useful sometimes. Now, every software program can set and use environment variables. We can actually see and use them in Eclipse. Project, Properties, Run and Debug Settings, and let me show you how that looks. So here we are in Eclipse, Project, Properties. We're going to go to this configuration and edit. And here are environment variables. Now, in order to see them, you need to choose Select. So notice, for example, here's my home directory sitting right there. That's the same home directory that we saw from the terminal. Here's my username down here. Now notice some are here and other environment variables aren't. There are only certain ones that are useful to Eclipse, and so that's all it brings in. Now, how do you use environment variables? Well, it turns out they're actually stored in hidden files. The location is dependent on the operating system version and configuration. There's usually a global file that's used by everyone, so it's stored in one of the system directories. And then there's another additional file that's used individually by a user. That way you configure your software exactly the way you want. When the system boots, the variables are read from the files. Usually the global file is read first, and then the user file is read next. So that gives the user a chance to override the things that are in the global file. Variables can also be added at the terminal or by other programs. This is done, for example, at the terminal by typing in export variable equals value. Now, when you do this, these don't get written to the file when your computer shuts down. This is actually kind of important. It turns out that if you corrupt these files, if you get garbage in them, you can make your computer virtually impossible to use. Sometimes this gets so bad that you actually have to reinstall the operating system if you don't know how to fix things like this. So these are not files you want to be meddling with, and so I'm not actually going to show you where the files are. But if you're going to look for yourself, the one you're looking for is usually called .bashrc if you're on a Macintosh computer, and it's going to be in your home directory. Now, it's not going to be visible. Because the file name starts with a period, you can't actually see the file. So you're going to have to do ls for list, and then a space, and -a. If you do that at the terminal, you will see all those files, including the ones that start with a dot. So there might be several surprises hidden there for you. Now, on Windows machine, this function is handled by the Windows registry. So it's a database that stores the configuration information. If you want to see the registry, there is a way to do it. You go to the command prompt, so that will be under Programs, Accessories Command Prompt, and type in regedit. Now please be careful when you do this. Do not change the registry. Remember, this is the configuration of your whole computer. If the registry gets mixed up badly enough, you're really going to have trouble. So don't make changes here unless you know what you're doing. So when the registry is corrupted, the operating system can't find programs, and programs can't find resources. Now, there are ways to corrupt the registry other than using regedit, although regedit works just fine for that purpose. Low-quality programs, for example, tend to corrupt the registry. So if you've been downloading a whole bunch of shareware from the internet, that can be a source of problems. Let's talk about what the test data should be for our program. Well, we're going to need to create a file of environment variables from the terminal. Now, I'm going to call it bashrc.txt. Like I say, I don't want to accidentally overwrite any of your files anywhere. Certainly, we should search for the first, the middle, and the last variable that gets set. This is checking the boundary conditions and something in the middle, something we've been doing all semester. We'd want to add new variables too, and search for the new variables that just got added to make sure they're still visible. And of course, after we do that, we might search for the first, middle, and last variable set again, just to make sure that adding new things didn't overwrite old things that we had there. Now, there's something very important going on here that I want to call to your attention. We're about to enter abstraction. Abstraction is incredibly important in computer science. In fact, it's one of the 7 principles, the 7 sort of big intellectual ideas that computer scientists have to master. So what environment variables really are is a relationship between a key and a value. So the key in this case is the name of the environment variable, and the value is the data it refers to. So for example, we have like the home directory and then the exact place where it's located on my system. This is a very general relationship and one that can be reused in many ways. It can only be reused if we provide a complete set of operations. Let me give you some other examples of similar things where we could use the same abstraction. Think about a dictionary. You have a key, those are the words in the dictionary, and the value would be the definition. So the abstraction that we create for environment variables would also work for a dictionary program. Think about cell phone contacts. The key would be the name of the person, and the value would be the phone number. Exact same abstraction. Notice that we've been able to find 3 different examples that have no relationship to each other whatsoever, that all use exactly the same kind of logic. This is great. This means if we write something for our environment variable class, we may be able to reuse it in a dictionary program and a cell phone contact program, and probably lots and lots of other programs. We'll talk about this more a little bit later. What should the design look like? Well, the data are going to be pairs of string references. So we have to think about what the implementation possibilities are. Now, we could use 2 array lists in parallel, with matching indices being used to pair the data. So, for example, we'd have an array list that stores the keys, another array list that stores the values, and we would know that the key matched the value if they were both at the same index. That's a possibility. We also could have an array list of string pairs. Now, at first, this may seem a little more complicated because it is going to require us to do another class. But think about the advantages. The string pairs will allow the key and value to be put together, and then they can be put in one array list. That's a better design. There are also lots of other possible data structures for this. In fact, if you take a data structures class later, you're going to see all kinds of interesting, clever, amazing ways of solving this problem. It's really a cool problem. Now, my choice here is going to be an array list of string pairs, because eventually if we use parallel arrays, they will get out of sync. It's just so hard to keep things like that correct. Whereas with a single array list, things are never going to get out of sync. We're never going to have a key shift to the next or the previous value, because it's really important to maintain the integrity of our data. I think that's the best design. Now, let's design our string pair class. For data, we're going to have two strings, a key and a value. And here are some methods. We'll have accessors for both fields, getKey, getValue, and a compareTo method. This will make things like sort and binary search possible to use later on. Now, I'm not actually going to use these in the program because the data here isn't big enough to warrant them, but it might be handy later on when we move to those dictionary and cell phone example classes. Of course, we'll need a toString method. Now, the thing that I don't have here is mutators, and there's a reason for that. In general, it's better to make classes immutable. Well, you'll say, well, what if the key or the value changes? Well, you know what? We can construct a new string pair. This isn't a large object, and so reconstructing it is just fine. That's really a much better design decision in many cases than creating a bunch of mutators and making your class mutable. There are some very difficult debugging problems that happen with mutable classes. So here's our design in UML, the string pair, the key and value, and the data. Notice I've made those private, as you can see by the little minus signs in front of them. And then getKey, getValue, compareTo, and toString. All of those are public, as methods almost always are. Now notice I've done this the way you usually do it in UML, and I have not listed the constructors, but we do need to remember to write constructors in code. So if you're not comfortable with that, make sure you put your constructors in the UML so you don't forget them, because that will cause you problems writing your programs, particularly with immutable objects. Let's think about the dictionary for a minute. Now, we decided that our data would be an array list of string pair, and we're going to need both accessors and mutators. Now, this one definitely is going to need to be mutable. So we need put, which will put a key value pair in, and we need remove, which will remove a key value pair given just the key. We're also going to need an accessor called getValue. That also takes the key, but this one returns the value, which is a string in this case. The issue that's important here is to remember that we need a complete set of operations. This is absolutely critical for reuse. If we forget even one operation, this class may not be reused and may not be used by other people. So the way you check for that is to look and see, do we have a way to find things, to add things, and to remove things? And can anything and everything be found, added, and removed? Well, if you look for add, you'll see that we have put. That's basically the add method. Find is getValue, and remove, of course, is remove. So it looks like we've got our basic bases covered. Now let's add some bells and whistles. You have to be really careful about this, and I'll talk a little bit more about the design decision I'm making here later. Do we need to be able to access the size? Well, one thing we certainly need to be able to access is empty. That is, we need to know if there's anything stored in this dictionary or not. If there isn't, well, then we probably shouldn't be doing search. So it turns out that's kind of an important method. Now the question is it strictly necessary, or is there a way we can work around it? Well, if you think about the methods we have right now, there isn't a workaround. There's no way to tell from add, put, remove whether there's anything in the dictionary or not. So isEmpty at this point is absolutely essential. It's a method we can't do without. Now, let's think about another method. If you think about that contact list example for cell phones, well, you know what? One thing we're going to need is a list of all the names that are in the phone. Because usually we're going to have a graphical user interface and users are going to be picking those names. So we need a method that returns all of the keys that are available. Now that will be an array list of strings. If we have that method, is empty strictly necessary? Well, at that point it isn't. And the reason is you can tell if it's empty by calling the keys method. If the keys method returns an array list of string that's empty, then we know that the dictionary is empty too. Now, you have to be careful here because an isEmpty method is a pretty useful thing to have. So I'm not saying that you shouldn't have it. But even without it, as long as you have the keys method, you would still have a complete set of operations. These are the really tough design decisions that you have to deal with as your programs get more complicated. So this design thing turns out to be a balancing act. The problem is this: when classes are missing critical methods, they're impossible to reuse. Let's say, for example, that we didn't have the put method there. Well, at that point, we can't add anything. Now, that's kind of a silly example because obviously it's useless without that. But for example, remove methods frequently are missing. Often there's a way to put things in but not to take them out. And that can really hurt reuse a lot. But then there's the other problem. And that's that if a class gets too big, if it gets too many methods in it, people tend not to use the class because they look at it and they think, oh my God, this is going to be so much work. It's going to be more work than implementing it myself. Now, I'm not very sympathetic to that point of view because it neglects the fact that that class that already exists has already been tested and is probably working more correctly than one that's brand new will be working. But this is something that people think. So, for example, when you're looking through the API and you see an API page that has like 12 pages of methods on it, the inclination to decide to do something else is really strong. So this is the balancing act. You need to provide enough operations so that you have a complete set, but not so many that people give up on your class and decide just to do it themselves. It takes practice. So, the need for creating a comprehensive set of methods and keeping the class size manageable is what needs to be balanced here. Now let's talk a little bit about the implementation. I'm going to do a bottom-up implementation. As I've mentioned, that's one of my favorite ways to do it. That means I'm going to create the string pair class first. We're going to put the data and the method and constructors in. Now, I've put the method headers in just to save us a little bit of time, and I've also Java docked it for you. These are things that you would normally have to do yourselves. It's not very interesting to watch me do it, so I'm not going to do it in front of you. But let's go to Eclipse and do the critical part of the code implementation. Here's our string pair class. Now our instance data was private, string, key, and private, string, value. Here's our constructor. Now notice we only have one constructor in this case. Because this class is immutable, we don't have any chances for fixing mistakes we make, so all of the instance data must be correctly and permanently initialized here. So our key is going to get the value of k, and our value is going to get the value of v. Now, these single letter variable names are a little bit obnoxious, but if I put key and value there, then we have to put the thises in. I guess I can show you that on one of them, just so you know how to work around this problem. So this dot key equals key. Remember, this is the implicit object. That is the object that's being used to call this method. And so that's the way you work around that problem if you have it. Now, when you get key, all we're going to do here is return key. So you probably noticed that these little classes like this, these little immutable classes, are extremely easy to write. For getting the value, you return value. Now this one's a little bit more interesting because when we're making a comparison between two string pairs, we only want to compare the key. Now there are a lot of ways this code can be written, but there's a particular way I like to write it. So we're going to have this dot key, so that's the key in the implicit object, dot equals other dot key. And we can return that. So we won't return false anymore, of course. Now that syntax may look a little bit scary to you. One way to make it look a little bit more friendly is to put in another string object. So let me show you that. And then here, we'll make the comparison to the other key. Now, if that makes it easier for you to understand, that's great. There's no shame in doing it this way. Obviously, the other way is a little bit more concise. By the way, one thing to notice about equals objects, when I created the equals method in the string pair class, I relied on the equals method in the string class. That's actually really typical. Equals methods tend to call other equals methods. Compare to methods tend to call other compare to methods. And constructors also tend to call other constructors. And so keep that in mind when you're implementing these things, because often there's a method already available that can do most of the work for you. Compare to is another example of this. Because we're going to just be comparing keys, well, this is really easy. In fact, we're going to do this dot key dot compare to other dot key. Now, this is the same syntax that I did the first time in the equals class. If you like the other syntax, you can modify it and put it in, but I'll leave both examples here so you have them both to work from. And here's our toString method. Of course, as always, we'll put in some strings. Now, this toString method, it's probably going to be used more for debugging than anything else, but it's kind of nice to have one of those around. It can make debugging a lot easier if things get tricky. Now, of course, at this point, we probably should be testing this method. As has become a bad habit lately, I'm not actually going to do the testing in front of you, just to save us a little bit of time. But remember, test often, test early, test small bits of code before you put them into big bits of code. You'll have a much more pleasant programming life. So now that we've created the string pair class, the next thing we're going to do is create the dictionary class. So we'll need to create the data, the constructor, and the methods. So here's our dictionary class. Notice our array list has been imported. And right here is our instance data. It's an array list of string pairs, and we've called it dictionary. This is our constructor. Remember, the goal of a constructor is to set up the instance data. So what we say is dictionary is new array list of string pair. Because we have only one element of instance data, well, that means we only have one thing that we have to initialize in the constructor. As a general rule, if you have X elements of instance data, there should be X things initialized in your constructor. And even if there's a case where that isn't true, you always want to check and make sure that it's okay that that hasn't been initialized, that it isn't going to break your class. Now here we need to insert a new key and value into the dictionary. Well, that's sort of interesting because the dictionary has a string pair in it. So first we need to create a string pair, and I'll call it element. We know we construct a string pair by using key and value, and then this is what gets added into our dictionary. Remember, dictionary is just an array list, and so we use the add method just like we do with any other array list. Well, that's kind of nice. But now the question is, are we able to actually keep our promises if we do this? Remember that keys were supposed to be unique, and we didn't do any checking before we did this insertion to make sure they were unique. So we really need to think that through. In particular, this is something that's going to come up a lot of different times, even with the remove method. So what would be nice is to look through the dictionary and see if this key is already in there. Now, that is so necessary so many times that it really deserves its own little private method. Now, this is something we didn't anticipate in our design, and that's fine. I called it find key index. Now, notice I made this method private, and it's really important that this be private. Notice that this refers to an index. No place else in the interface to our dictionary did we use the word index at all. In other words, somebody looking at our dictionary class doesn't know that there's an array list hidden in here. This is good encapsulation. This is the way design is supposed to be done. So when I called this method with the word index, that means it has to be private to keep our secret that there's an array list hiding around in here. Now, you might think we could use something like contains, but we've got a problem there. Contains relies on an equal method to be available. You might think we could use binary search, but remember we didn't keep our array list in sorted order. It turns out that in Java there's some touchy things about being able to get this to all work out, and we're not really ready to do them. So we're just going to have to use a plain linear search here. So we're going to do a for loop. I think I'll do a for each loop because I think that makes sense. Oh, wait a minute though. Because I have to return an index, a for each loop doesn't make sense. Remember, for each loops don't have access to the index. So let's say index is 0, index is less than dictionary.length plus plus index. If key equals, well, let's think about what we want it to equal. We're going to have a string pair that comes back from dictionary.get of index. So that's a nice little pair, but we're only going to compare to the first element. So let's create a string, which I'll call first, and that's going to be pair.getKey. Now, you can put all the stuff in one line, but it tends to get kind of confusing. Whereas if you separate it out into different lines, you can really think carefully about what type of object is being returned. So for example, when we call dictionary.get, we know that our dictionary has string pair objects in it, and so a string pair is what gets returned. If the key equals first, then we return the index. Now, if we get to the end of that for loop and we haven't found anything, that's when we return -1. Oh, and I see I made a mistake here. I've been programming too much with arrays. I forgot that because dictionary is an array list instead of an array, you use the size method instead of using the length data. So there we go. We've got our find key index method. So now we can go back and deal with our put method. So if find key index of key is not equal to -1. Well, let's think about what happens in that case. That means there's already a key in here that has that index. Well, in that case, we're not going to put a second key in. So we should just return. Now, you could make a different decision than that. You could decide to remove that first key and put the second one in. That would be fine. Really, the thing that's important is that it's correctly documented right here in the Java doc. Because if it isn't there, then people won't know about it and they'll get confused. Okay, so let's think about remove. Well, that's going to give us another opportunity to use our little method we just wrote. So if find key index of key equals -1, well, that means that that key wasn't found. Well, if we don't have the key, we can't remove it, so we should just return. And otherwise, we should do dictionary.remove at index. So notice we're letting the array list class do an awful lot of the work for us. Whoops, I see that I forgot to save this at an index. So let's improve this code a little bit. So now I'm saving it to a variable name. Then I'm checking to see if that variable is -1. And then removing the index at the end. When we need to get a value for the string key, guess what? We can use our same method again. So here we're going to have int index is find key index of key. Now we need to think this through carefully, because when we do a get from the dictionary, that's going to return a string pair object. and we're trying to find its value. So what we're going to return is pair.getValue. Once again, because pair is a string pair object, that means only the methods in the string pair class are going to be accessible to us. Those are the only things that are going to work. So you'll notice when you start to get more classes in your programs, it becomes really important to remember exactly what type each object is. And usually declaring a few more variable names will really help that out. Now I'm not going to leave all that ugly empty space in there. So there's our nice little find key index, which notice we've reused already 3 times. That's kind of cool. IsEmpty comes directly from the dictionary class, so we're letting it do the hard work. And here's the keys method. Let me go through that one with you for a minute. First, I created an array list of strings called results and constructed it, so it's initially empty. Then I went through the string pairs in the dictionary one at a time and put the key into the array list of strings, and that's what gets returned at the end. Nice way to do it. So now we've implemented the string pair class and the dictionary class. The last thing that's left to do is to create the driver. So let's think for a minute about what our driver should do. Well, we should read the configuration file. Now, I'm going to show you a trick with the configuration file that you haven't seen before, I suspect. And that's we're going to use a command line argument. Now, there are a couple of reasons I'm doing this. One is that it's some kind of cool programming. We've been putting in that string square bracket args thing all semester, and we really haven't used it for anything. So I thought it might be nice for you to see it in action. In order for this to work, we need to create that name of the file in Project, Properties, Run and Debug Settings, just where we went before, only we're going to go to Program Arguments. And we'll put the file name in the box. So let me show you where that is. So Project, Properties, here are Run and Debug Settings. So this is what we're going to edit. And here are the arguments. So the program arguments, remember we decided to call it, or I decided, I guess, I don't think you really had a voice in it, bashrc.text. So that's okay. And that's okay. So that way we now have this in our method. Now, if you're wondering where it got the name of a command line argument, when you don't call programs inside of Eclipse like we usually do, you call them from that little terminal thing. And that terminal is called a command line. And the way a command line works is first you give the name of the program, and then a space, and then the name of the file. So that's where it got its name from. So that should be kind of a fun thing to do. Let's go to our driver class and put that in. Well, the first thing we need to do is to make sure that we can get it from the arguments. If args.length is 0. Well, we need to think of what we're going to do in this case. If args.length is 0, remember args is a string array. You can see that right up here in line 18. What that means is we didn't get our command line argument. That's kind of a problem. So we probably want to tell the user about that. So no configuration file was found. Now you can need to decide whether we should quit the program at this point or go on. Since it is possible to continue without a configuration file, I'm not going to quit the program, but that is another option that's available. Now, if args length isn't 0, then we're hoping it's 1. So we're going to have then else string file name equals args of 0. So the first command line argument, there's only one in this case, args of 0, because arrays are 0 indexed, goes into the file name. Now, once we have the file name, then we need to read the file. So let's take a look at our read file method. It's going to take a file name, and it's going to take a dictionary object, which I've called env. So we're going to have to implement that method. We've been reading files with scanners. So you're certainly familiar with that line of code. Looks like I've gotten inordinately fond of N's, so let's fix the spelling there. As always with reading a file, while file.has next line. So we'll have a string. Line is file dot next line. And then we need to take that line and add it into the dictionary. Now you may have noticed that over the top of this method is a method called add to dictionary. So we're going to have to deal with that method eventually, but we can use it now even though we haven't written it yet. So we'll do add to dictionary, the line at env. And of course, the last thing we want to do is to close the file so that we don't have Eclipse unhappy with us. Now we need to deal with that add to dictionary. Remember, the format of lines in the file is key equals value. So we can actually use that equal sign to our advantage to pull things apart. So let's do that. We've got our line. So we're going to have a string called key, and we're going to get that as the part of the string line that comes before the equal sign. So the way you find that, I'll call it index equals. We're going to take line and then find the index of the equals. Now, one thing that will tell us is whether we even have an equal sign in the line. If we don't have an equal sign, we don't want to be entering it as a value. So if index equals -1, which is the value that gets returned if it isn't found, then what we should do is just return. That is, get out of here. And it's not a bad idea to make a little comment there to let people know what's going on. If there is no equal sign, there is no key value pair. Add nothing to the dictionary. Now, if it's not equal to -1, that means that we found the equal sign. So the key then is line.substring, starting at 0 and going to index of. Now, we haven't used substring in a while. I'm sorry, index equals. There's a quirk to substring that you may not remember because we haven't used it in a while. That first index is inclusive, and the second index is exclusive. So what that means is 0 is included and index equals is excluded. So notice that works really, really well for this particular case. In fact, this is one of the reasons that substring is written that way. We also need to get out our value. Now here we're going to do line.substring. Well, we need to start at index equals +1. And we need to end at the end, which is line.length. One thing to remember here is that line itself is a string, and as such it's immutable. So when we're creating these substrings, key and value are actually new substrings. They're not part of line at all. So there's no danger in this. We haven't damaged line. At this point, we're now ready to add these into the dictionary. So we'll do env dot, and we need to remember the name of our add method. So we can go look it up over here. So we called it put, and it takes 2 string arguments, which are the key and the value. So notice this class does not know about the string pair class at all. That's kind of nice. It makes it easier not having to wrestle with more classes in here, just being able to let the dictionary do the work. This is where good design really pays off. Okay, so let's go back to our main program. So we created our dictionary. We've got a scanner to interact with the user. If there's no configuration file, we didn't do anything. If there was a configuration file, we got the file name. And then we called, or we should call, read file with the file name and environment, our dictionary. So that gets some data read into our environment file. Now I've got an infinite loop here, and notice I've marked that it's infinite on purpose. So we print line, enter the variable name to see the environment variable, or variable equals value to add a new one, or quit to exit. So then we read in the line from the keyboard. If it equals quit, we just exit. Remember, we don't save the file here. That was really critical. If it has an equals, if the line contains equals, then that's when we add it to the environment. Well, we have a method for that now. It's environment dot add to dictionary. It takes the line first. Whoops, and it's not environment.add to dictionary. Environment is passed as a parameter. Now, otherwise, well, in that case, we have variable equals value. And guess what? We've already added a method to deal with that. That is add to, we don't have a method to deal with that. That's not adding to the dictionary. So our other case, which maybe I better put a comment in to help us out here, is do a search. Well, I guess I already have a comment on that if I would just read it. So to do a search, we're going to do environment dot get value for line. So notice in this case, we're pushing the work off into the dictionary class. Well, that's our main program, so I guess it's time to do a little bit of testing and hope for the best. Now, we've written an awful lot of lines of code without testing anything. Let's hope we don't pay for that decision shortly. So no configuration file was found. That's not a good thing. Now we see I have a bashrc.txt, and it was all in little letters. Probably a good time to check our environment variables and see if I put it all in little letters too there. So we go to our properties. Now that's interesting. I wonder if this is what the problem. It seems to have several different configurations. So let's delete those configurations and just work with one. Let's edit that configuration. So we're looking at the arguments. It's bashrc.txt, and it's all in little letters. So that looks okay. Now remember, I did remove those other two configurations, so I have changed something. So let's rerun the program again and see if things are behaving better. No, it still didn't find our configuration file. So that's a problem. Well, let's make sure it's in the right place. So here's our environment variables, and here's our bashrc.txt. Now this is the data. I cut and pasted it from the terminal window. So that looks good. So we still have a little bit of debugging to do. So let's think a little bit about this. So args.length has to be coming in as 0. So somehow it's not finding our command line arguments. So let's go and take one more look. Well, now that's interesting. It reset them for us. Well, that is probably a problem. So let's go edit that one and see if we have our, So as you can see, these command line arguments are a little bit complicated to deal with inside of Eclipse. Let's see if we've got them now. Good. So it found our file at this point. That's a good thing. Don't let that scare you away from using command line arguments. They're actually really handy in a lot of cases. Probably not a bad idea to look and see what some of the variables are. So we have one that's called groups. It's just a couple of parentheses. We've got hist size that should be 500. So let's look at this. So that's interesting. It didn't find groups. It didn't find hist file. Let's try adding something and see if that works. So let's say hist file equals 300. And then hist file. Something isn't working very well. So it's time to go back to our driver and see what went wrong. So first we see if the name equals quit. By the way, notice the quit was working, so we know that's okay. Now, if the line contains equal, then we add the line to the environment. That looks good. And otherwise, we get value from the line. Well, that looks good too. So let's take a look and see what's happening here. So we have our index equals. Is the index of the equals? That looks correct. If index equals is -1, that is if it's not found, then we should just return. Then we pull out the 2 pieces and put it into the dictionary. That looks pretty good. Let's see if something went wrong here. Now notice both of our things are going wrong at this point. That is, both reading from the file and the search were going wrong. Adding things in at the command line was going wrong. So the problem is almost certainly an add to dictionary, even though it looks good. So let's think about where things could go wrong. Well, one thing that could be wrong is maybe I didn't remember how index of worked correctly. Let's go to the API and take a look. Here's our string class. And we're looking for the index of method. Remember, they're in alphabetical order. So we use the one with the string. So it returns the index within the string of the first occurrence of the specified substring. The returned index is the smallest value of k. If there's no such value, then -1 is returned. Okay, so the right thing is returned there. So that's kind of funny. So I guess it's time to pull out some of our better debugging tools. Let's go over to debug mode. And think about where we want to be when we check. I think right about here is a good place to check. If we stop here, we'll be able to see what both key and value are, and that will be very useful for us. So let's run the program now in debug mode. Remember, when you run in debug mode, you use the little bug icon. So we're right there, and let's look and see what key and value are. So key is bash, and value is that. So key and value look like good things. So then we're doing env.put. Well, now this makes me wonder if maybe we didn't do that put method correctly. But let's keep going a couple more times and see if we get the right thing. So here's the next one. Bash argc, and that's 0. And here's the next one. So now we're stepping through the lines in the file. And notice those all seem to be coming correctly. Now I say this based on the yellow columns over here. So it looks to me like that put method is the one we should be suspicious of. Now the put method is in the dictionary class. So let's go and look at the dictionary class and see what happened with that. So here's the put method. So if find key index is not equal to -1. So let's think about that for a minute. If we're putting it in there, we don't want to find the key already. So when the key is -1, we want it to be successful. So I think that maybe we could rewrite this logic a little bit better if we wrote it like this. That is, if it isn't found, that's when we want to put it in. So that makes sense. So we created our new string pair, and then we did a dictionary.add. Dictionary.add should be working fine. I wonder if our find key index is working well. So let's take another look at that method too while we're here. So we started at 0. We checked to see if index is less than the size, and then incremented it. That looks good. So we get the pair from that index. We find the first element, and then we see if the key, that's the one that was passed in as the parameter, equals first. If it is equal, we return index, and only when we get to the end when it's not equal do we return -1. Well, you know what? That looks pretty good too. But maybe we need to step through that a line at a time. That may be our next target. Let's actually check and make sure things are still behaving the same way as we gather more information about how our program is working. So let's look for bash, because we saw that one added in. You know, I have a thought. I don't know if we gave the user any feedback in our driver. In other words, this might just be a silly driver mistake. Let's take a look at that and see what's happening again. Aha! Well, look at that. I got this, but I didn't show it to the user. So this is really foolishness going on here. So if we do a search, well, what we want to do is actually print this out. Otherwise, we don't know if our search has been successful or not. Now, when things get added, we might think about whether we want to print something out to say whether it's successful or not. Because we can tell from the search, we probably don't have to. Let's run our program again and see if things are making more sense now. Now I'm going to change over to our bashrc.txt file so we can check for things. So let's check for bash. Ah, that's looking better. So EUID 501, host name. Notice this is the last one. That one looks good. So I've checked the first, the middle, and the last. Now we need to add one in. So let's say path equals userlib. And then we're going to search for path, and we get userlib. Well, oh yes, we were going to check then again, remember, for the first, the middle, and the last. Just to make sure we hadn't overwritten anything. And that's still correct. So now it looks like our program is working. Well, that was some silly stuff, but at least you got to see the debugger used a little bit more. So that's always good. Now, we have something really profound that happened in this program that I want to bring to your attention. We actually used a very advanced design technique. It's something that's called a facade. Design patterns are a really cool part of computer science. You aren't going to be able to study them very comprehensively too soon because they're kind of advanced. But on the other hand, I want you to point out that this is something that we've used. If you think about what a facade is, it's a fake front. And that's basically what we did in our dictionary class. So the work behind the scene is all array list, but the dictionary itself looks like something very different. So this is kind of a neat trick. So what we did was hide the interior workings of the class from the world. So for example, notice how carefully I concealed the index. The index is the thing that gives it away, that tells us that it's an array. And so I kept the only method that used an index private, so the exterior world couldn't see it. It's really good programming. Now, this trick is something you use when you have to do something quick and dirty. So maybe your boss or your company needs something right now, and your intention is to go back and put in something much more elegant and beautiful. For example, it would really have been nice if we had sorted our array list. Then we could have used binary search on it. These are really important things in terms of efficiency. One thing I will say about the facade design pattern, though, is that there's a saying in computer science that there's never time to do it right, but there's always time to do it over. So you have to be careful about doing this too often. It can be really hard to get the time to go back and fix things like this, and also make sure that when you do it, that you are actually documenting it well so that somebody else can see that this is something that needs to be done. That will help you remember. One of those little to-do comments in Eclipse is one of the ways of doing that. Now, let's talk about the Java API again. Believe it or not, the Java API already has classes for this. And, wouldn't you know it, the name of the class is Dictionary. Now, when you're new to Java programming, knowing all these class names is virtually impossible. This is something that progresses as you become more and more familiar with the language. Also, the dictionary class is deprecated. We talked about deprecation a little bit earlier in the semester. What it means is that there's an implied threat that the dictionary class is going to be removed in the next version. Now, the dictionary's been deprecated for quite a while, so once again, I actually don't believe Java's implied threats. But that's also a way of the API people telling you that this isn't the right class to use. This is an old-fashioned one. We've left it around because people have used it, but really in the future you need to use something else. Now, it turns out this class looks exactly like what we designed except for a couple things. One is that it uses generics, just like our ArrayList class does. So while we've created one that has 2 strings, this one you could use any 2 classes. The other thing is the keys method returns something called an enumeration instead of an array list. Enumerations are kind of cool. They're one of the ways that you step through things, but it's not a technique we've done, and so we really couldn't do that. Also, there are 2 additional methods that we didn't implement. This is where the completeness thing comes in again. One is called values. So just like we had a method that returned all of the possible keys in an array list, we can have a method that returns all of the possible values. In this case, it would return them as an enumeration. Now, there's also a size method that returns the number of key value pairs. I've never really understood exactly why the size method is necessary, but maybe there's some situation that it is necessary and that I haven't encountered yet. It turns out the class in the API that replaced dictionary is something called map. Map is an amazingly wonderful, cool class that's used all over the place. It's part of the Java Collections framework, just like ArrayList is, but it's a little more complicated class. You're going to study that in more advanced programming courses. For example, the CS 2334 class at the University of Oklahoma. So keep programming.